Okay, I had a big problem in my last video. I don't think my sound recorded. So let's try it again. I'm going to go really quickly this time because I don't have much time before my house gets filled with people. So this is Chapter 8, Lesson 1, Reflections. Just a note, make sure you bring your test and your homework because we're going to have a homework quiz on Lessons 1 and 2. So all your problems need to be filled in. If not, you need to get help with them on the help board. The homework quiz, I'll just have I'll just say write down number 2 and number 16 from your homework, and you just copy them out of your homework. If you have blanks in your homework, you can't put anything down, and you'll lose 5 points a problem. There's no partial credit on homework quizzes because you're supposed to have all the right answers. So just a little warning, make sure that you bring your extra credit. That's worth 10 points if you do it, so that's a pretty big deal. And I sent you an email with that on there. If you still need it, you can email me. All right, we're going to start doing a different type of chapter. It's called transformations, and we're going to start out our transformations by talking about reflections. As usual, lesson 1s are pretty easy. So a definition is reflection of a point through a line L. The reflection of a point through line L is point P prime such that L is perpendicular bisector of PP prime if P is not on L. All right, what that is saying is, look over here. If we have C prime is reflection if this line is the perpendicular bisector of C prime. So down here they drew lines connecting C and C prime. So this line, if this line is the perpendicular bisector between C and C prime, then it's a reflection. And if you look, it's perpendicular and it's a bisector. This is equal to this. Therefore, C prime is the reflection of C through line L. So anytime that you're told that something is a reflection, you can assume that the line between them divides it evenly, provides the midpoint, and is the perpendicular bisector. So it's going to be perpendicular, and these two segments are going to be equal. Same with W. W prime is a reflection of W along line L because it's perpendicular and it's a bisector. You can also construct a reflection, and I did this in the one I didn't have sound to. So we have point P over here, and we want to come up with P prime. So all you do is you put your point of your compass on point P, you draw a random arc, then you put your compass, you label the points where they intersect line L, A, and B, put the point of your compass on A, draw an arc, put your point of your compass on B, draw the same arc, and where they intersect is the reflection of point P. That would be P prime. If you drew the line from them, these two would be congruent and it would be perpendicular. The reflection of a point is the same distance and it's perpendicular from the line L. Then we have a transformation theorem. It says reflection of a pair of points through line L preserves a distance. So if we reflected A to A prime and B to B prime, the distance from A and B and A prime and B prime are going to stay the same. So I did an example. I did a couple problems from your homework for that. Let's see if I can get that up here. Here we go. Let's see if I can move it in the recording area. Maybe I can't. There we go. So this is problems 26 through 32. I did them in the last video, so we can just look at them real quick. We're going to draw. This is that problem that I just showed you from the theorem, where they had A and B and A prime and B, and they said it preserves the distance when the points reflect. So we're going to prove that AB is equal to A prime B prime. They help us through with a lot of little hints. First of all, they tell us to connect all these lines that are connected there, and that's 2 points to determine a line. Then it says, what relationship does line L have to A prime, B prime? And we would know that it's the perpendicular bisector, because if the points are reflected, that's what's given. A is reflection, A prime is a reflection of A, B prime is the reflection of B. So if we know it's a reflection, then we know that line L is a perpendicular perpendicular bisector of both this segment and this segment. Then they say, why is this triangle, ACD, congruent to A prime CD? It's a perpendicular bisegment. This segment is congruent to this segment. These two angles are congruent because they're perpendicular. They form right angles. Right angles are equal. And CD is equal to itself, reflexive. So these triangles are congruent by side, angle, side. Then it says, why is AD equal to A prime? AD, A prime, and angle 1 equal to angle 2. Well, if the triangles are congruent, then the parts are congruent by CP, CTC. Congruent triangles have congruent parts. Then it says, what relationship does angle 1 have to 3 and 2 have to 4? Well, they form right angles. They form right, they're complementary. They add up to 90 degrees. And then 30 says, why is angle 3 equal to angle 4? Well, if 1 is equal to 2, then angle 3 is basically congruent to 1, and angle 4 is congruent to 1, and are complementary to 1, so complementary angles are equal. Triangles are congruent because of side, angle, side, because of CP-CTC and perpendicular bisector, and AB is congruent to A prime, B prime because of CP-CTC. If these two triangles are congruent, then their parts are congruent. So that's the real quick version of the one I recorded without sound. So hope that helps, and I'll have another video for you tomorrow.
Hi everyone. I should do that more often.